Hello everybody. So today we're going to talk about solving equations with variables on both sides. So when you have variables on both sides of the equation, it's best to combine all the variables on one side of the equation as soon as possible. Now that doesn't mean it has to be the first thing that you do, but you should do it sooner rather than later. So here we've got a problem: 15 minus 2x equals negative 7x. So what we want to do, we've got variables here and variables here on both sides. I'm going to move these over here with these. Okay, so when I add 2x, it cancels these out, leaves me with 15. Over here, it leaves me with negative 5x's. Okay, and now I'm going to divide by negative 5. It's a pretty easy problem at this point. And x comes out to be 15 divided by negative 5 is negative 3. So there's my answer. Put a box around it. Okay, now you should check your answer. So, how do I check my answer? I take my answer and I put it back in the equation everywhere there's an x. So this is going to be 15 minus 2 times negative 3 equals negative 7 times negative 3. And what I want is I want these two sides of this equal sign to be the same. So, negative 2 times negative 3. I do the multiplication first, not the subtraction. I use my order of operations. So negative 2 times negative 3 is positive 6. So this is 15 plus 6. And over here, negative 7 times negative 3 is positive 21. And 15 plus 6 is 21. Both sides are equal. That proves that this is my answer. Okay, so there you go. Okay, now this is another simple problem, except I've got a little bit of extra work to do because I've got parentheses and I've got numbers outside I need to distribute. So I need to take this negative 2 and distribute it inside here. So negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10. Okay, over here I'm going to distribute the 6. So 6 times 2 is 12. And 6 times negative 1/2 is negative 3x. Okay, again, I have x's on both sides. So I'm going to add these 3 x's to both sides, because I like my x's to be positive whenever I can. So this is going to be negative 2x plus 3x is going to be x, plus 10 is 12. And then I'm going to subtract 10 from both sides. And I get x is 2. Piece of cake. Okay, now here, I've got 3 problems for you. I would like you to do these on your own. So go ahead and pause the video, write these problems down, and solve them, and then jump back on here and compare your answers. Okay, so on this one, I've got x's on both sides. I'm going to subtract 2x from both sides here. And I get negative 5x equals 19. And then I'm going to divide by negative 5. And I get x equals negative 19/5. And just go ahead and leave it like that. That's a pretty simple fraction. It terminates. So if you wanted to change that to negative 3.8, it would be okay. But I would just leave it like that. Okay, this one. I've got y's on this side, I got y's on this side. So I'm going to subtract 2.5 y's from both sides. It's going to make all this go away, leave me with a 6. Over here, this is going to be 2y minus 1. Now I'm going to add 1 to both sides. And I get 7 equals 2y. And then I divide by 2. And I get y equals 7/2. Or you could change it to 3.5 because that's a nice decimal. But I would just leave it as 7/2. Okay, finally, this one's a little different because I got to do this distributive property here. So I'm going to distribute this inside. 6 times 4 is 24. Minus 6z equals 2z. I'm going to move my 6z's to the other side by adding to both sides. And so I'm going to get 24 equals 8z. And then I'm going to go ahead and divide by 8. And I get z equals 3. All right. I don't really like this z, so I'm going to rewrite that for you so it looks good in your notes. All right, so hopefully you got negative 19/5, 7/2, and 3 for your answers. Okay, let's take a look at these. Let's just focus on this one first here. Okay, go ahead and pause the video and solve this and see what you get, and then jump back on here. All right, this one, as you might have discovered, is kind of weird because you want to combine your x's, so you go, okay, I'm going to add 4x to both sides here. And these cancel out and those cancel out, and you're left with 3 equals negative 7. What in the world does that mean? We know that's not true. Well, if you solve an equation and all the x's disappear, you get something that's not true right here. That means, wait for it, there is no solution to this problem. Okay? So here's what happens in real life. This is a line, and this is a line. And what would normally happen when you set them equal, you find where those two lines cross each other. So you graph the two lines and they cross like this, and the point of intersection where they cross is the answer. Except, here's what happens. This is a line with a y-intercept of 3. 1, 2, 3. And a slope of negative 4, so it goes down 4 to the right one. And so you end up with this line right here. Looks like that, and we'll make it a nice green line to go with that problem. Okay. Now this is also a line, has a y-intercept of negative 7 and a slope of negative 4. So what happens there? Well, 1, 2, 3, 4, 5, 6, 7. Got a slope of negative 4. 4. So it goes here. All right, this line looks like that. And what happens is those end up being parallel lines. They never intersect each other, so they don't have a solution. Okay? So that's how you deal with that. Whoops. All right, let's look at this one. Go ahead and pause the video and give this one a try. 6x plus 4 equals 4 times 3/2 x plus 1. So pause it and let me know what happens here. Okay, on this one, I need to distribute the 4 into this parentheses right here. So I didn't do anything here. I just write it down. 6x plus 4. 4 times 3 is 12 divided by 2. That's 6x plus 4. Okay, you can probably see it right now. If I subtract 6x from both sides, I get 4 equals 4. Okay, my x has disappeared again. But this time, my equation's true. 4 is equal to 4. What does that mean? Well, if you look at that, this line and this line, they're the exact same line. They both have a y-intercept of 4. 1, 2, 3, 4. And they both have a slope of 6. 1, 2, 3, 4, 5, 6 over 1. So they're both very steep lines. And they look like this. Okay? They're right on top of each other, which means everything is a solution to these. Okay, no matter what number I put in here, let's say I put 0 in here. 0 times 6 is 0 plus 4. is 6 times 0 plus 4 is also 4. If I put in 10, that'd be 64 equals 64. If I put in negative 2, this would be negative 12 plus 4 would be negative 8. It'd be the same thing over here. So everything is a solution to this. We say it has infinite solutions. Everything's a solution to this thing. Okay? All right. What about this? Area of a circle can be found with the equation A equals pi r squared. Okay, so a little review here. R stands for radius. This is your radius. It goes from the center to a point on the circle. Pi is the number 3.1. We always say it's 3.14, but it's really not. It's 3.14159265355. And you know what? It's not even that. It just keeps on going forever and ever and ever. By the way, the world record for memorizing pi out is over 40,000 digits. Okay, so anyway, these two circles here are identical, which implies the radii have to be the same. Remember, radii is plural for radiuses. Okay, so what's the area of each circle? Well, how do you tell that? I don't know what the radius is. Well, I can figure it out. Now, here's the tricky part. This is a radius, x plus 2. This is a diameter, 4x. So what I need to do is I need to convert this to just a radius. And if the whole diameter is 4x, that means the radius is half of that is 2x. Okay, now I know that 2x equals x plus 2, and I can solve this. Just subtract x, and I get x equals 2. All right, now, I'm not done. That's not the answer. I take this, and I plug it in here, and I get 2 plus 2. The radius is 4. So now I know the radius, I can figure out the area. The area is pi times 4 squared, which is 16 pi. Now I don't know what the unit is. Okay, so I'm just going to leave it like this. 16 pi. I could multiply that out. I don't know what that is off the top of my head. But if you do multiply it out and get a decimal, you need to put an approximation sign. So it looks just like an equal sign, except it's squiggly. It's approximately equal to. It's about 52 point something, I believe. But we'll just leave it as 16 pi. Okay. Next. A boat travels X miles per hour upstream on the Mississippi River. And on the return, the boat travels 2 miles an hour faster. How far does the boat travel upstream? Okay, so it went the same distance no matter what, right? So what that's saying is that it went X on one trip, it went X plus 2 on the other. Okay. Actually, that's not true. So here we have some stuff in the picture. Always look at the pictures here. It's got some information. It says it went 3 hours one direction. Okay, so it went 3 hours upstream, 3 times X, there we go. Then it took 2.5 hours to come back downstream. So this equals 2.5 times X plus 2, because it went faster. So remember, X is in miles per hour. It went 3 hours, so that'll figure out how far it went. Okay, so the first thing I need to do is distribute this 2.5 in here. So this is 2.5x plus 2.5 times 2 is 5. Okay, now we're going to subtract 2.5x from both sides. 3x minus 2.5x is just 0.5x. This goes away, I'm left with 5. Okay, next, I'm going to divide by 0.5. So x comes out to be 10. And that's in miles, so I need to put the unit on there. So I went 10 miles. Now I could check that. If I took the 10 and I plugged it in here, I'd get 3 times 10 is 30. Over here I'd get 12. 10 plus 2 is 12, so that'd be 12 times 2.5. Whoops, not 0.25, 2.5. Okay, so 5 times 2 is 10. Carry my 1. 5 times 1 is 5, plus 1 is 6. 2 times 2 is 4. 2 times 1 is 2. Add that up. That's, I have one number behind the decimal. I got to put one number behind the decimal. 30 equals 30. 10 times 3 is 30. So I checked it, and I got my answer right. This would be a good problem to check, too, because these story problems can be tricky. Okay, so here's your assignment. You're going to do 1 through 45, just the odd ones, and then I will see you in class. Have a good day.